Review the concepts. Number 11.1. Suppose a linear probability model yields a predicted value of big Y that is equal to 1.3. Explain why this is nonsensical. Answer. Number 11.1. Because big Y is binary, its predicted value is the probability that big Y equals 1. A probability must be between 0 and 1, so the value of 1.3 is nonsensical. Number 11.2. In table 11.2, the estimated coefficient on black is 0.084 in column 1, 0.688 in column 2, and 0.389 in column 3. In spite of these large differences, all three models yield similar estimates of the marginal effect of race on the probability of mortgage denial. How can this be? 11.2. The results in column 1 are for the linear probability model. The coefficients in a linear probability model show the effect of a unit change in big X on the probability that big Y equals 1. The results in columns 2 and 3 are for the logit and probit models. These coefficients are difficult to interpret. To compute the effect of a change in big X on the probability that big Y equals 1 for logit and probit models, use the procedures outlined in key concept 11.2. Number 11.3. One of your friends is using data on individuals to study the determinants of smoking at your university. She asks you whether she should use a probit or logit or linear probability model. What advice do you give her? Why? Answer 11.3. She should use a logit or probit model. These models are preferred to the linear probability model because they constrain the regression's predicted values to be between 0 and 1. Usually a probit and logit regressions give similar results, and she should use the method that is easier to implement with her software. Number 11.4. Why are the coefficients of probit and logit models estimated by maximum likelihood instead of ordinary least squares? Answer 11.4. Ordinary least squares cannot be used because the regression function is not a linear function of the regression coefficients. The coefficients appear inside the nonlinear functions of capital Phi or big F. The maximum likelihood estimator is efficient and can handle regression functions that are nonlinear in the parameters.